right, let's get started. My name is Rob. I've been doing GitHub Advanced Security for a couple of years now. I'm a GitHub trainer, for example, so I train a lot of people using the tools that we have there. And this has now come available, I think 2 weeks ago, on the Azure DevOps side as well. And in Xperience, we've already had some experience in the betas that we had there. We have a bootcamp ready to go, for example, to train our customers. And I wanted to share a little bit more on what actually GitHub Advanced Security is and what it can do for you inside of Azure DevOps as well. And it's not something you can just turn on and then say we're more secure. We really need to think about how can we embed this in our organization. And if you look at our history as an industry, then you see on average vulnerabilities that we have in our system, in our application, in our dependencies, for example, they go undetected in the source system itself, so the library that you're using, on average for 4 years. And even if you start thinking about that, we had a big scare a year and a half ago, sort of, was the Log4j attack that were there. Everybody was up in a hustle. We need to figure out if we're using Log4j, for example, we need to do something in there. That vulnerability had been inside of that source code for over 7 years. So that is where we stand as an industry right now, and that is why I like to dive into these features, because we can really improve on these averages if we start looking into what we have there. Same goes for credential leaks, for example. What we see is that this is the most used attack vector because it is so super easy. If I get your credentials into your cloud environment, for example, if I'm a hacker, I can actually go in there and do fun stuff. And we see these credentials being leaked everywhere because it's super trivial to leak them out. These are some numbers from last year. Only looking at GitHub access tokens, but we have the same personal access tokens on the Azure DevOps side, of course. And these numbers are just scary. And it's not that these are just grabbed somewhere from out of the air. These are real numbers of how many secrets has GitHub found, only looking at GitHub access tokens, for example. And maybe you've read the news last week, or maybe 2 weeks ago, there was a big leak where somebody leaked an access code to an Azure Blob Storage account from Microsoft, and they leaked 38 terabytes of data through that single credential that was leaked in there as well. So we really need to improve our security stance and get better at doing this. Similar, if you look at how many things are we actually deploying in production. Depending on which research you follow, these numbers can even be higher, but usually we as developers, we don't reinvent the wheel every time. We pick up a library from the open source community. You don't build your own encryption, for example, anymore, or you don't build your own ORM to talk to the database, for example. You pull something from the open source community and start using that. But that means the stuff that you deploy into production has not been created by you at all. So we need to do something there to improve. So we really need to first be aware of what the heck are we actually building on top of, what are the dependencies that we have there, and then we need to be aware of, hey, what versions do we have and what do we deploy to production. And I like to usually explain that. We call that a dependency chain through a visual as well, saying, hey, this is your application. And especially if you live on the Azure DevOps side, you probably are using something like C#, for example. You pull in a couple of packages where you say, these are the things I want to use. I have an ORM, like Entity Framework, pull that in, so I don't have to write all that code myself. But the thing is, these packages that we have in there, we call them top-level dependencies. Those are your direct dependencies onto something from the open source community. The developers that have built that have the same thing as you. They don't want to reinvent the wheel, so they use something from somebody else. So this goes a layer down as well. And this is what I always call turtles all the way down. It is really impactful. This keeps on going and going until there is a library that everybody uses. So probably your dependencies will have dependencies, and guess what? Those dependencies will have dependencies as well. This is what we call the supply chain, and the scary part is what happens if one of those dependencies has an issue in there. This is how we came to learn about Log4j, for example. There was a dependency issue there inside of Log4j, and a lot of applications were building on top of Log4j. Well, we first need to be aware that we're actually pulling in a package that is using Log4j, for example, and then we can start remediating that. Well, these are some of the examples that Advanced Security will help us with. Knowing that we actually have a dependency with an issue is step one. But then fixing it is super slow in most environments that we see. These are some averages that we see looking at the numbers. especially from the GitHub side, for example. They can track until, hey, we had an issue in a package that uses Log4j, for example. How long does it take for a repository to no longer pull in that specific package? In the meantime, to fix that is over half a year. So we have that average of a dependency. A package could have a vulnerability inside it for over 4 years. That was the average that we had before. Once you know it, getting to fix it can also take another half a year. And in the end, we're all developers. We know how things go. Mistakes happen. We need to embrace that. And I am here to show you a couple of functionalities that you can use and leverage to become a little bit better. So how can we protect ourselves against those security risks? And that is, of course, where GitHub Advanced Security for Azure DevOps comes into play. I usually refer to that now as Advanced Security, as a suite of DSS functionality that you have there. And I like the stance that GitHub has on this. This is why they built this product as well. Initially, they built it on the GitHub side, and now they brought it finally over to Azure DevOps as well. So we need to bring this power, this knowledge, firsthand into the developers themselves, the engineers, because they have the capabilities and the opportunity to fix those things as well. It's not that we do something after the fact, send it to a security team, and then figure out when we are going to fix something. We give the alerts into the hands of the people that can actually remediate them. Well, what is GitHub Advanced Security? There are 3 main pillars that you need to be aware of: dependency scanning, secret scanning, and oh nice, code scanning is in the bottom. I see I have a mistake in the slides here. But we'll just roll with it. 3 different things: dependency scanning, secret scanning, and code scanning. So let's first talk about that supply chain. Usually when I do this in a big room with people around there asking for feedback, saying who here is responsible for security? Who here is aware of the packages that they're pulling in? And usually you see hands dropping then already, and then you say, who is then responsible in your team for keeping everything up to date? Especially on the NuGet side and C#, we've seen that it can be quite a hassle. If you do this once a year, you usually rely on the most senior person in your team to every once in a while say, hey, NuGet, update all your dependencies, because then usually stuff breaks. We're still sort of in dependency hell. There's a lot of moving things there, so you run in the pull in updates and stuff will break, so you need to figure out how that works. The harder that is, the longer people wait for pulling in updates. And every once in a while, we as consultants as well, we join a company, start helping them out, and then you see them still running on versions that were ages ago. And in this fast-moving world that we're in, usually that means there are dependencies that have vulnerabilities in there already. So let's quickly switch to an actual example of how this works inside of GitHub Advanced Security for Azure DevOps. How can you set up code scanning and what can you learn from that? So I have the de facto standard repository in Azure DevOps, Tailwind Traders. So you can even use that if you want to play around with these things, and you have the capabilities and functionalities enabled, which is a good thing at least to note as well. This is a paid product. You can enable that on top of your Azure DevOps environment. On the GitHub side, it can be used for free if you have public repositories. On the Azure DevOps side, it is a paid product. But still, this is very good embedded into the product itself. So this can definitely help you become more secure as well. Let's double check where my mouse is. I have Tailwind Traders, and the way that stuff works inside of Advanced Security is you enable that per repository. You can even enable that on bulk. And then you can start using the functionality that is in there. And most of the functionality is configured by running it inside of your pipeline. That gives you control over when you want to execute these checks. And that is then the nice integration into Azure DevOps as well. So if I pick up our default CI pipeline for the build, we have a YAML pipeline in here. You see that we have a normal build. We set up Node. We set up npm install for everything that we have. We restore the packages from the package ecosystem that we use. We do a normal build, and then we run Advanced Security dependency scanning. So that is an extra task that is available when you've enabled Advanced Security. You can use it. There's no little to no configuration around it saying, hey, this is the task that I use, run it. Do be aware that you need to run it after the build for .NET, because the build integration spits out a lot of extra information that dependency scanning uses for that as well. Once this pipeline has ran, we can even go to an execution, for example. Let's do it from here. No. You can see in the logs that are available information about all the dependencies that it found. So let's just open up that stage. And here we have the dependency scanning in here. And you get a nice table that says, hey, we checked for all these types of different dependencies that were there. Cocoa Pods is integrated, Gradle, for example, NPM. And then it says we found 1,500 different NPM packages that this Tailwind Traders demo application is already using. That's NPM. And then for NuGet, we have 94 more packages that are there. That is a starting point, knowing what kind of dependencies you have. And then the nice integration is that if you go to repos and advanced security, you get an overview of these are all the dependencies that you have inside of your application. And from those dependencies, it scans that with the known version that you have in there. So we're using system.drawing.common, for example, with version 4.70. It can then match that against the National Vulnerability Database that's been created on the US side. And GitHub Advanced Security has an extra layer on top of that to figure out, hey, what kind of dependencies issues are there. There's lots more to dive into that as well, but I'll skip over that. The main thing is there's a database that says, hey, this specific version of that package has a vulnerability in it. It has a severity link attached to that as well. And we give you that information as a developer saying, hey, there's an issue in one of your dependencies. You probably want to fix that. You can dive into each alert and then see what is happening, saying, hey, we're using a vulnerable version of system.drawing.common. If you upgrade to the latest patch release, then you already fixed the vulnerability because that is the version they have fixed the issue in. You get a deep link back into your project file, for example. This is where you have pulled in that specific dependency. And you can even see that on the right saying, hey, we have a vulnerable package, system.drawing.common. And we're actually pulling that in because we're using Microsoft Application Insights ASP.NET Core. So that whole dependency chain is squashed down to saying the vulnerable package that we found at the bottom is system.drawing.common, and the root dependency that is pulling it in is your Microsoft Application Insights ASP.NET Core. Yeah, that's where I want it to be. Yeah, good one. So you get all that information, and the nice thing is that it also says something about, hey, what is actually happening in here? So me as an engineer, I can actually see what is happening in here. There's a vulnerability that parses graphic files in here, and I can educate myself as well, saying, hey, this is a known pattern, for example, so I should not at least do that in my own code, but this is happening inside of this dependency. You can even click on the advisories that are there for this specific one. Sometimes there's a lot of more text in here. And you can really educate yourself saying, hey, this is the .NET Core remote code execution vulnerability that was found inside of system.drawing.common. And you get way more information from the vulnerabilities that is in here as well. Yeah, let's leave it at that because I can talk for an hour about this screen particularly. So I won't do that for this webinar, but we can always dive deeper if you need to, for example. This is the GitHub.com advisories database. This is the overlay that they have on top of the National Vulnerability Database, where GitHub is actually reviewing all the alerts that are in there, saying, is this something we should give an alert to our users for, yes or no? And the nice thing is that they're really ingrained into the community, so they can have a conversation with the creators of those packages as well. And I've seen things where creators can actually say, hey, this is not something that is actionable. You will never ever be able to hit that in production, for example, and then they can dial down the criticality of the alert that is in here. So all sorts of options to educate yourself and then, of course, deploy the fix. And the fix is then usually upgrade to the latest version. We hope that people actively do responsible disclosure where they go back to the maintainer first and then they say, hey, I want to make sure that we have a fix before we send out the alerts. So that is the part for dependency scanning, knowing what dependencies you have, and then get alerts for the things you need to fix. And in this case, we have a lot of stuff in this repository that we need to fix. Let's see where I was again. We're already halfway through, that goes fast. So that is dependency scanning. Well, the next pillar is secret scanning. That is what I alluded to in the beginning. Secrets are one of the most easiest way to attack somebody because it's super easy to accidentally spool your secrets into the logs, for example, of your repository, or even worse, inside of your repo. And we need to scan for those and find them as well. Most of the time I see people have no idea whatever is in their repository, and then you enable secret scanning and you find all sorts of stuff that should not have been in the repository itself. And since these are Git repositories, that means that everybody who has a copy of that, probably all your colleagues, will have those secrets on their machine as well. So we need to spread that sprawl, but first be aware of what is happening inside of your repositories. Secret scanning on the GitHub Advanced Security side has been built with partners, where partners share the way that you can recognize the secrets that they have. And there are over 100 at least already that are there. Most of the big corporations have shared that, saying this is how you can recognize a SAS token for Azure Blob Storage, for example, or a connection string to a SQL database. Stuff like that is in there, and especially the personal access tokens for all these services, that is where they focus on. Well, to show you how that works inside of GitHub Advanced Security for Azure DevOps, I want to quickly show a demo as well. And all that lands on the same location. You need to go to Advanced Security on the repo level, and then go to Secrets, where it will show you all the secrets that it found. What happens is that as soon as you enable Advanced Security on your repository, it will scan the entire history of the repository for those known patterns, where they look for a GitHub personal access token, for example, always starts with GHP underscore. The modern one start with GitHub underscore pod, PAT, I think. So you can recognize those secrets from those patterns that are there as well. So as soon as you enable that on your repository, a background job will start, and it will pick up all the secrets that you have in there, and then nicely generate an alert for you so that you are at least aware. So we can dive into one, for example, saying, hey, there's an identifiable Cosmos DB master key in here. It is stored in this specific location with that specific commit, for example. So it can really do the triaging and figure out what has happened and how it came to be. And it's nice that the remediation always says, hey, just accept that this thing has been compromised. Everybody who has done a Git pull since this was committed will probably have that. So rotate the secret, make sure that it doesn't happen again, store it securely, for example, fix that. But Cosmos database identifiable key is one of those things that it will pick up. So if we go to the location, again, this is a deep link to the file itself. We have an app settings.json, and that was accidentally committed into the repository, and now everybody can have access to that. So this is even a Mongo database string. And apparently they picked up somehow saying that this magic string that is in here is a master key and it should not be shared. As I said, there's a lot of partners who are working on making this better. I like the way that GitHub has approached this and saying, instead of doing security by obfuscation, that you have a 16-character string, for example, have no clue what is in there, they choose to make it reliable and saying we have a prefix. If you see that prefix and it has this length, then definitely this is one of ours. And then you can at least act upon those as well. This is something you don't have to build into your pipelines. It is immediately enabled on the repository when you enable Advanced Security. And then you can even go one step further. If you have the rights to set it up for your repositories, you can go in there and say, I'm using Tailwind Traders. And I can then also enable push protection on those secrets as well. Push protection is really cool because that is where the fun starts. Until so far, it has scanned the entire history of what we have in there, but now that we've enabled push protection for those secrets as well, I can even do a demo, go back to the files of this repository. Let's just open up the markdown file, for example, edit it, and then grab, for example, a personal access token. I usually do this with my personal GitHub account because I know that works very reliably, but you can also pick up other tokens. There's a whole documentation that gives you an idea of what kind of tokens are picked up. I'll just generate a classic one. And of course I need to authorize for that. Two-factor authentication is important. We call GitHub Advanced Security for Azure DevOps GASDO in a friendly way because that makes things super easy. I'll just generate that. I'll revoke it immediately after the fact. So you won't be able to do anything with it. Let's say I am a developer, I did something on either my local machine, for example, and now I want to commit that to my repository and do a git push. Now that push protection has been enabled, it will scan the incoming changes while they are being sent over to Azure DevOps, and then immediately says, hey, the push is rejected because we picked up a secret. And the secret is in demo markdown on that line. These are the tokens that are involved. So I can go back, remove the token from the commit, and then I can push the commit through, for example. So the first step was scanning your entire history of everything you have in your repository. The next step is then push protection to, as we call it, stop the leak, stop everything from coming in, fix it on the developer side, because nobody else has now access to the secret because it hasn't been pushed to the server yet. The push has been rejected, and that works with whatever client-side IDE you have. For example, if you use a plugin, something for Visual Studio Code, it will reject it on push as well. So now you can rewrite the history on your local side and fix this and prevent extra stuff from coming in. So if I change that and say this was a secret, I'm basically rewriting what I want to commit, and now the commit goes through because there's no secret in the changes anymore. Just to make sure, I want to revoke that secret so that it cannot be misused. But that is one of the powers that secret scanning does on the Azure DevOps side as well. So that was a quick demo, looking at the time. Let's dive straight into the last one, code scanning. Because that is the third pillar that is in there. So we had seen dependency scanning, we had seen secret scanning, and code scanning is really cool stuff. Code scanning is running on top of CodeQL, and CodeQL stands for Code Query Language, where it actually looks at your code. It picks up all sorts of semantic meaning from your code and dumps that into a database, hence the query language, of course. And in the database, it stores that method A is calling method B. It picks up certain parameters that go into method B. In method B, it sees you pick up the parameters, wrap it in a constant, for example, and pass that into method C. And then with code scanning, you can run certain queries on top of that. And those queries have been built by the open source community. There's a very active security community for those as well. I think there's a lot of queries being added every week. And they look for things like, hey, that input that you had on top, is that, for example, sensitive information, a password, for example. And in method C, are you pushing that out straight into the logs? That is a pattern that you should not be doing. So an anti-pattern, because that makes that your password is in clear text in the logs. You should not be doing that. And there's a query to pick those things up. There's lots of different query types that are there as well. The nice thing is that we can run a query against the database. And as soon as that query has a result, an alert is generated into code scanning, and then we have a code scanning alert that we can fix. It's super interesting to see how they've been handling this, because they made that on the GitHub side immediately transparently open to the community and saying, hey, we cannot build everything ourselves. And they invited over the entire security community to look into the queries that are there. And I think this is even an older number. There's a lot of open source community contributions for this specific repository. I can share the link afterwards, and then you can really follow along. But it is a super active repo where people are actively building up queries, saying, I build that query as well, because they get some attribution for that as well, and share that into the engine that is powering CodeQL as well. So we get, for free, extra queries almost every week into the product as well, and then build from there. For those things, we can see that if we generate those alerts to the end user, we see a 72% actual fix rate on those things. So this is stuff that people usually weren't aware of, but thankfully through running the code scanning queries, they now see, hey, there's an anti-pattern that I should not be doing there. Maybe I should at least scrub the password before I dump this entire object into the logs, for example. GitHub is, of course, GitHub. So when they do these kinds of things, they do wrap that into analysis as well, saying what happens whenever we do there. And they checked, for example, the CVEs, the errors that are available into JavaScript code that came out for a certain period. And they ran that on the default set for CodeQL scans that are there, and 24% would already have been fixed just by running that set. So this is an indication of how powerful running code scanning on your code as well can be as well. So let's dive straight into a demo, and then we'll have some time for questions. I'm very aware that we have a short amount of time for this, but I at least wanted to give you that overview. This is again part of, you need to embed that into your pipeline, because this scanning tools need to have that information from your pipeline saying what the heck is happening in there. I probably should just open up the edit mode for this. There are a couple of tasks that you can include for that when you have this available. So there's an advanced security CodeQL init task that you can start with that actually has some settings as well. It picks up these different languages where you can say, hey, scan, run all the queries on C#, for example, or JavaScript, pick those up. Well, we have that in Tailwind Traders, so I've configured it for that. And then you can select one of the different query suites. We usually use default for the demos, and there's more deeper queries attached to security experimental, for example, and quality even looks at code qualities, for example. The initialize step task initializes the database, sets up the environment, saying, hey, we're going to analyze C# and JavaScript. Then you can run a build of your code. In this case, I'm running with auto build that tries to automatically build your code. But if you want to have more control, you can match that, swap that out with your own building components. And then in the analyze step, we actually analyze run all the queries on the database, analyze results. And if there are results, we create code scanning alerts. And in the end, there's also a publish step that publishes all the things that it found back into the system so that alerts can be generated from this as well. Well, how will you see the results? Everything is under advanced security again. So we have the 3 different tabs, and under code scanning, we can see that, hey, we found issues. We found some results on some queries. This is a very simple one. SQL query built from user control sources. Hopefully most developers actually know that they should not be doing that. You need to parameterize everything, for example, to make sure that you cannot have SQL injection attacks. But you would be surprised to see how many people have no idea what SQL injection, for example, is. So again, we get a description saying, hey, SQL query is built using string concatenation. That's a bad practice. You shouldn't be doing that. Here's a recommendation. Here's an example. And then you get a full code example of what is in there as well. But you can also go back to MSDN articles, for example, or even the common weaknesses enumeration and learn more about what is happening here. Well, having the alert is one thing, of course. You want to get that deep link again, show me the actual code where this is happening. And if you know how this part of the code works, then you can see that we have a string concatenation here. Apparently the username is coming straight from the input from the user, similar with the password. So we have a possible SQL injection attack here. So that is how GitHub Advanced Security for Azure DevOps integrates into Azure DevOps. You put things in your pipelines, you will scan them, and from that you will get alerts. There's of course tons more even to show on that. If you want to know more, then check out these links. Feel free to connect with me on LinkedIn as well. Because this is where we regularly share extra webinars that we have, for example, stuff that is coming in. I like to dive into the differences between GitHub and Azure DevOps, for example. So definitely reach out there as well if you want to know more. Some questions that came up is this stuff that we can try it out for free, for example? On the GitHub side, you can try that out for free. On the Azure DevOps side, it is a paid license. But the nice part is that they've included this into the Azure billing setup. So you can do this on a pro rata limited basis. So enable it for a couple of days and you only pay for those days as well. Another question was, how does that work? Somebody already knew that this is working by checking the active committers in the repository, and that takes up a license seat, for example. They check the last 90 days for a repository, all the activity that was there. Everybody who has contributed to that repository will take up a license seat, for example. But again, that goes through advanced billing. A pricing question again is $49 based on users per month. Are there other options for the enterprise? That is definitely talk to your Microsoft representative, of course. But this is the basic license fees that I have seen as well. So not sure how that works if you buy this stuff in bulk. Is Advanced Security also able to scan Docker images? Good question. Out of the box, currently it doesn't, because GitHub has said it's better that we push that into vendors who really know how Docker containers work. They really focus on the package ecosystems. That's why we see NuGet support, for example, NPM support in there. What you can do, it's currently not available yet, but you can scan, for example, your Docker images still with Trivy. Trivy will spit out a serif file, it is called, and the serif file is the part that you can upload back into Azure DevOps. They're still working on implementing that upload part, but that will then integrate all the alerts that are coming from the Trivy scan straight into your code scanning results as well. And you'll even see that annotated with a different tool name. So currently they show as CodeQL. If you do that with Trivy, it will show as Trivy as well. It's already available on the GitHub side, but not yet on Azure DevOps, but I think that is coming soon. And if you have follow-ups, then definitely check out the short link here on top, Xperia.do/Gasdo. That is where we share the news that we've seen on the Xperia side. And that's also how you can ping us, for example, if you want to have a follow-up. We have a full day bootcamp on this stuff as well, where you can get a hands-on with your team into this as well, checking out how that works for you in a controlled environment, so we don't do anything on your side yet. So definitely reach out if you want to know more. All right, and I think with that, we're nicely around this time frame that we wanted to see. So I'm going to say goodbye, and then we'll see you next time. Thank you.